Okay. In the last class, I told you about the optimization method to find out optimal weights for a model. If you want to recollect whatever we have learned till now, this diagram will help you for that. See, initially we start with input data whose targets are also known to us. So I am specifically stressing this word target. Input data with known targets. Okay. Suppose age of the person along with the blood pressure of that person. So age is input, okay, and blood pressure is the target, okay, or the output. So by taking that input data, what we do is we select a machine learning model. We fit a model. So with training data as input, what we do is this action is called fitting a model. So by taking in training data, we fit a model. Okay. This can be a classifier. If your task is classification, we have to fit a classifier model. If the task given is regression, we have to fit a regression model. Like that, based on what you want to do with the input data, okay, or what you want to learn, we fit a model. Okay. For all the examples that we have discussed till now, we assumed that we always want to do regression analysis or we want to fit a regression model. Okay, so in our case, with the assumption that we want regression, okay, our model will look like this: predicted value y cap, okay, is equal to predicted value y cap is equal to some bias b w naught plus w1 into x1. Here the training data is made up of the input feature x1 and the target label y, where the feature x1 is age and the target label is the blood pressure of the person. Like that, you have considered how many samples, say first example, second example, like that. We have considered 100 examples. 100 examples. Means you have gone to a hospital and you have taken 100 records of patients who have already visited, already hospital ki vachi వాళ్ళ ఏజ్ బీపీ చెక్ చేయించుకున్న వాళ్ళ ఏజ్ బీపీ ఇన్ఫర్మేషన్ తెలిసిన రికార్డ్స్ ఒక 100 తీసుకొని ఫ్రమ్ దట్ హిస్టారికల్ డేటా యూ ప్రిపేర్డ్ దిస్ training data set. Okay, it comprises of 100 examples. And we learned how to fit a model. How, uh, why do we fit a model? What is the purpose of this? The purpose of fitting a model or learning a model is tomorrow, if an unknown person comes, tomorrow, a person who hasn't visited that hospital till now, ఆ హాస్పిటల్కి ఇప్పటి వరకు రాలేదు, ఫర్ ద ఫస్ట్ టైం ద పేషెంట్ కేమ్. Okay, what the model will do is the model will simply ask his age. Okay, the model will simply ask his age. Okay, so with the help of this age, with the help of this age, the learning model will now predict the blood pressure of that person. Will now predict the blood pressure of that person. It won't use any BP measuring operators. You don't require any doctor. You don't require any BP blood pressure monitoring operators. You just need this model running on a computer. So a person who is familiar with working on a computer, he will ask the patient, what is your age? The patient will tell his or her age. And the operator will give that age as input to the learning model. Okay. And immediately the model will say, this person, this patient, blood pressure is so and so. Okay. The model predicts. Okay. So whatever is predicted, whatever is predicted, that is known as y cap. Okay, that is known as y cap. See, before the model is used, before the model is used for predicting the blood pressure, we have to assess that this model is working properly. See, you cannot launch any product in the market unless its performance is good. Okay. Similarly, whatever model that we have fitted using the training data, what we do before we give this model to a hospital, before we sell this model to a hospital, first of all we should check whether the model that we have fitted has learned properly by measuring its performance. Okay, so what we do to measure the performance, we compare the predicted value y cap with the already known value. అదేంటండి ఆల్రెడీ ఎట్లా తెలుసు బీపీ అని అంటే ఏం లేదండి. వాట్ వీ డూ ఈజ్ ఆఫ్టర్ వీ ఫిట్ ద మోడల్ ఫర్ ద ట్రైనింగ్ డేటా, we take randomly a record from the training data. For example, for the second record, if the age is 35 and if his blood pressure is say 79, what we do is for this person, for this record, we give the input 35. Okay, and if the model says his blood pressure is 85, what is his actual blood pressure? Actual blood pressure is 79. So we learned in one class, we learned what are the various loss functions. Okay, how to calculate loss for a given predicted value and the actual value. Okay. So you have calculated the loss or the, if you accumulate the loss anedi, it is only for one example. If you accumulate the loss for all the examples in the training set, means we select randomly another record from the training set, say 50th record I will select. His age is 42 and his blood pressure is say 90. Okay. This is when the doctor measures his blood pressure. His age is 40, sorry, his age is 42 and his blood pressure is 90. So what we do is we select this record and we give the input 42 to the model. So the model predicts. This is the prediction for which record? Second record. And this is a prediction for 50th record. If the model predicts that his blood pressure is say 100, and what is the actual value? Actual value for 50th patient, actual value is 90. So the difference between these two, actual and the predicted. Okay. So actual is 90 and the predicted value, these are the predicted values. So the predicted value is 100. So the error or the loss for this example is 10. Whereas in the previous case, the actual value is 79 and the predicted value is 85. So for second example, the loss is 79 minus 85. For the 50th example, 90 minus 100. So like that, we calculate loss for all the examples in the training set. Okay. And we accumulate the loss, mean value or sum of all the losses or sum of the absolute values. Like that, we accumulate the loss. Okay. And you found that the loss is very high. The loss is very high for this model. Let us assume that in this model, the only unknowns are W0 and W1. To make it more simple, let us assume that W0 is 0. Just to make it simple, we assume that W. So the only parameter the model has is W1 weight. Okay. Let us assume that whatever model that we have fitted, it has weight W1 is equal to say 4.2. So you found that for this model, the loss is too much or the cost is very high. So what we do is we use optimization methods which we have discussed in the last class. We use optimization method, and what we do with the optimization method, we try to we try to what we do with this optimization method, we try to update W1. In the previous class, by mistake, I told you that during optimization, the loss will be updated. It is not the loss. During optimization, the weights of the model will be updated. Sorry for that mistake. You have to correct that. Okay. So the optimization method will update the parameter of the model. In our case, the model has only one parameter, that is W1. So the model updates W1. Okay, when you update the weight, your model is also updated. See, when you update instead of 4.2, if the optimization method says don't go for 4.2, the cost is too much or the error is too much, you make it 3.5. So instead of 4.2, so initial weight is 4.2 in the first iteration. So the optimization method says don't go for 4.2, go for 3.5. So your model has been changed. Now your model says the predicted value of BP is equal to 3.5 times age. Okay, once again in the second iteration, we take one example at a time from the training set. Okay, give the input to this model, calculate the predicted value, and find out the difference between the predicted value and the target value, and finally calculate the total cost or total error for the updated model. Again you found that the error is too high. ఇంకా ఎర్రర్ ఎక్కువగానే ఉందండి. ఎర్రర్ in the sense a root mean square error between the predicted and the actual value, or mean absolute error, mean bias error. We have found several, we have learned several methods to calculate error. So because the error is still high, what the optimization technique will do is, again it will update in the third iteration, it will update the weight. Once again it says don't use 3.5, still the error is high, you go for say 2.2. Okay, so like that, in an iterative approach, using gradient descent method of optimization, the weights of the model are updated. And when do you stop updating the weights, or when do you stop your optimization method? I told you in the last class there are three conditions to stop. Okay, um, we stop this iterative approach of updating the parameters of the model whenever we reach the least possible error value. Okay, see, this error or the cost is a function of weight. See, listen carefully. This error or loss function purely depends upon the parameters of the model. The parameters of the model in this case is simply W1, weight W1. So if W1 is not properly selected, you will get very high error. If W1 is the ideal value or optimal value, you will get the least possible error. Okay. In order to make you more clear about this concept, I will show you an animated video to make you more clear about this concept. I will show you an animated video. See, can you see the window? Can you see the window? My
Yes, sir.
desktop? Okay.
Yes, sir.
So towards your towards left of this diagram or the window, what is given? The cost value is given. Okay. So here the cost value is given. Just wait for a minute. Okay. So what is given here? The cost. Okay. What is the cost function in this case? Can any one of you tell me what is the cost function in this case? Here you are looking at an expression. What this expression is? T is the target. Here there is a slight change in the notation. T is the target or actual value. Y is the predicted value. So absolute value or the difference between actual value and the predicted value whole square, and sum of this for all the examples. So what is this cost function called? Sum of the squares of the error. What is this cost function called? Sum of the squares of the error, SSE. If you divide this by number of examples in your training set or number of examples for which this error is calculated, okay, then you will get mean square cost or mean square error. Okay. So this is a function. This is a mathematical function. Okay. So do the if you expand this, so what you will get, cost is equal to, okay, actual value minus predicted value. How do you get predicted value? X1 plus sorry, x1 into w1. This is how you calculate the predicted value. Okay. Here what is x1? Age of the person. What is y? His actual blood pressure. So what is the only unknown here? W1. What is the only unknown here? Weight, W1. So this is your loss function or cost function. Okay. So what we do is we differentiate this function with respect to W. So D C by dW1. In other words, what exactly we are calculating? Change in cost divided by change in weight. ఓకే, ఇక్కడ వెయిట్ని పారామీటర్ అన్నారులేండి, పి అన్నారు. సో డిసి బై డిపి. సో డిసి బై డిపి. సో ఇన్ దిస్ కేస్ వాట్ ఈస్ దిస్ వాల్యూ? Change in cost value divided by change in the parameter value. Change in cost by change in parameter. This is not there. P1 ఏం కాదు, P. What is y-axis value? Cost. What is x-axis value? Parameter. So change in y divided by change in x. What is this value? Slope. Okay. Rate of change of cost with respect to change in the parameter. So in our case, the parameter P is equal to W1. Okay. And the cost function, rate of change of the cost or the error with respect to the change in weight W1. Okay. What is the initial value that we have considered in this case? What is the initial value? Look at this. How much is this weight W1 initially? Roughly 0.25. 0.25 is the initial value. Okay. So just look at the animation. See, once again I will run. First, look at the animation. Observe. Are you able to see the animation that I am playing here?
Yes, sir. Yes, sir.
See, I have passed this animation. So this is for the initial case. This is for the initial case when your weight is 0.25. Look at the model that you have fitted. Look at the model. This is a graph between x value in this case is what? What is the input for our model? Age. And what is this predicted value? Blood pressure. Okay. So or it రాశారు చూడండి. Look at this. What is this target T? Target T in our case is blood pressure. Okay. Okay. ఇది ఇటువైపు తీసేద్దాము. So target T in our case is blood pressure. Okay. Now for weight W1 is equal to 0.25. This is the model that you have predicted. ఏంటది? Y cap is equal to predicted blood pressure is equal to 0.25 times the age. ఇది మీరు జస్ట్ యూ లుక్ ఎట్ దిస్ మోడల్. ఇక్కడ మోడల్ అంటే ఏంటండి? యు ఆర్ ఫిట్టింగ్ ఎ లైన్, యు ఆర్ ఫిట్టింగ్ ఎ రిగ్రెషన్ లైన్. సో దిస్ ఈస్ ద ఈక్వేషన్ ఆఫ్ ద రిగ్రెషన్ లైన్. ఓకే. సో ఇది బాగా యాక్యురేట్గా ఉన్నట్ట లేనట్ట? చూడండి, ఫస్ట్ పర్సన్కి యాక్యురేట్ ఉందా? ఎస్. ఏజ్ 0, బ్లడ్ ప్రెషర్ 0, మ్యాచ్ అయింది. ఓకే. సెకండ్ పర్సన్ తీసుకోండి. ఓకే. సెకండ్ పర్సన్ ఏజ్ ఆర్ ఎక్స్ వాల్యూ ఈజ్ దిస్. ఓకే. సెకండ్ పర్సన్ యాక్చువల్ వాల్యూ ఎంత అండి? 25. ఇది 25 యాక్చువల్ వాల్యూ. బట్ మన మోడలు ఎంత ప్రిడిక్ట్ చేసిందండి ఈ సెకండ్ పర్సన్కి బ్లడ్ ప్రెషరు? దిస్ వన్. దిస్ ఈజ్ అ ప్రిడిక్టెడ్ వాల్యూ. డూ యూ సే దట్ దెర్ ఈజ్ అన్ ఎర్రర్ ఈవన్? ఎస్. ఇక్కడ చూడండి, అన్ని ఎర్రరేనా? ఎర్రర్ కూడా ఎక్కువ ఉందా తక్కువ ఉందా అన్ని ఎగ్జాంపుల్స్కి? ఎర్రరు ఎక్కువ ఉందా తక్కువ ఉందా ఇక్కడ? అసలు ఒక్కదానికన్నా యాక్చువల్ వాల్యూకి దగ్గరలో వచ్చిందా? ఆర్ యూ ఏబుల్ టు హియర్ మీ? టోటల్ ఎర్రర్ బాగా ఎక్కువగా ఉంది. ఫర్ ఎగ్జాంపుల్ ఈ ఎగ్జాంపుల్ తీసుకుంటే ఈ పర్టికులర్ పర్సన్ యాక్చువల్ వాల్యూ ఎంతండి ఈ పర్సన్కి? ఇక్కడ ఉంది. అండ్ సారీ, యాక్చువల్ వాల్యూ ఇది. ఇతను ఏజ్ ఇంత, ఎక్స్ వాల్యూ. ఇతనికి బ్లడ్ ప్రెషరు యాక్చువల్ వాల్యూ ఇంత, అరౌండ్ 50 ఉంది. వెరాజ్ ప్రిడిక్టెడ్ వాల్యూ చూడండి ఎంత తక్కువ ప్రిడిక్ట్ చేసిందో. So what is the error for this particular? ఇది ఎన్నో పర్సన్ 1 2 3 4 5 6 7 8th పర్సన్ ఈ 8 అండ్ 9th పర్సన్ చూడండి ఎర్రర్ అసలు ఇంకా చాలా ఎక్కువ ఉంది. దిస్ ఈస్ ద ఎర్రర్ ఫర్ ద నెక్స్ట్ పర్సన్. ప్రిడిక్టెడ్ వాల్యూ ఇదండి. ప్రిడిక్ట్ చేయడానికి మనం ఈ రిగ్రెషన్ లైన్ ఇస్తాం. అతని ఏజ్ చెప్పగానే సపోజ్ అతని ఏజ్ 40 ఇయర్స్ అన్నాం అనుకోండి, ఇక్కడ ఒక వర్టికల్ లైన్ గీస్తాం. ఈ 40 ఇయర్స్ ఏజ్కి ఎంత అనేది ఈ రిగ్రెషన్ లైన్ ఇస్తుంది. ఇక్కడ ఇంటర్సెక్ట్ అవుతుంది. 40 ఇయర్స్ వర్టికల్ లైన్ గీస్తే ఇక్కడ ఇంటర్సెక్ట్ అయింది కాబట్టి ఇతని బీపీ ఎంత అకార్డింగ్ టు రిగ్రెషన్ లైన్? మేబీ ఒక 15 ఎంతో ఉంటుందండి. జస్ట్ ఫర్ ద సేక్ ఆఫ్ ఎక్స్ప్లెనేషన్ ఐఎమ్ టెల్లింగ్, డోంట్ టేక్ దీస్ వాల్యూస్ యాజ్ రియల్ వాల్యూస్. ఓకే, బట్ ఇతనికి ప్రిడిక్ట్ చేసింది 15 అయితే బీపీ, యాక్చువల్గా ఉన్న బీపీ ఎంత ఇతనికి? అరౌండ్ 100. Around 100. Okay. So like that, you all agree that this model is the worst model because the cost is too much, as is evident from this. What is the cost at step 1? While the animation is going on, or while you watch this animation, you please observe this value cost. So initially the cost is too much, 10.9, around 11. Okay, so once again I will play this animation. Just one iteration, after one iteration you look at the cost. What is the cost now? Earlier the cost was 11. Now the cost is 4.385. what happened in the second iteration? ఏం జరిగిందండి? ఇందాక వెయిట్ ఎంత? W1 వెయిట్ 0.25. నౌ మన గ్రేడియంట్ డిసెంట్ మెథడ్ వెయిట్ని ఎంత అప్డేట్ చేసింది? నౌ వాట్ ఈస్ ద వెయిట్? అరౌండ్ సే 0.9, around 0.9. okay, this is 1. So sorry, this is 10. So the weight is around 10. So what is this value? Say 8. The weight is 8. So from 0.25, initially the weight is 0.25. Now the weight is updated to 8. Okay, and as a result of this change in the parameter value, your cost reduces by around 7 units. Earlier it was 11, now it is 4 point something. Okay, this is the second iteration. Okay, now third iteration. So what is this dotted line represents? What this dotted line represents, you tell me. ఈ dotted line ఏంటండి?
Slope.
What is this line? Good. Slope? Slope. If you simply say slope, it is not complete. Slope at what point? Slope when the weight W is equal to say 12. Suppose if this is I1, first iteration value, second iteration. So slope at point I3, slope at this point. Okay, look at the cost function, it has reduced further. Now it is around 2. In the at the end of the in the second iteration it was 3 point something. In the first iteration, the cost was around 11. In the second iteration, the cost is around 4. And in the third iteration, the cost has reduced to 2. And what is your objective? To reduce the cost as much as possible. How do you reduce the cost? What is the difference between the earlier model and the present model? ఇందాక లైన్కి ఈ లైన్కి తేడా ఏంటండి? ఇందాక యూ హ్యావ్ సీన్ ఏ లైన్ లైక్ దిస్. What is the difference between the earlier line and this line? Slope. Okay. అంతే కదా. Now the slope of the line is in the third iteration, the slope of the line is 12. అంతే కదండి. This is of the form y is equal to mx plus c. C is 0 in our case, and m is nothing but the weight. Slope is nothing but the weight, and x is nothing but the age, and y is nothing but the blood pressure. So ఇక్కడ మనం రెండు స్లోప్స్ వాడుతున్నామండి. లెఫ్ట్ హ్యాండ్ సైడ్ ఏమన్నా స్లోప్ ఆఫ్ ద కాస్ట్ ఫంక్షన్ క్యాలిక్యులేట్ చేస్తున్నాము. స్లోప్ ఆఫ్ ద కాస్ట్ ఫంక్షన్ ఆర్ గ్రేడియంట్ ఆఫ్ ద కాస్ట్ ఫంక్షన్ క్యాలిక్యులేట్ చేస్తున్నాము. బేస్డ్ ఆన్ దట్ స్లోప్ we update the parameter w1. ఈ అప్డేట్ చేసిన పారామీటర్ తీసుకొని మళ్ళీ ఇక్కడ న్యూ లైన్ని ఫిట్ చేస్తున్నాం, న్యూ మోడల్ని ఫిట్ చేస్తున్నాం. అంటే అప్డేట్ చేసిన స్లోప్ తీసుకొని ఆ న్యూ స్లోప్కి తగ్గట్టుగా ఇక్కడ ఒక లైన్ రిగ్రెషన్ లైన్ గీస్తున్నాం. ఓకే. సో ఫస్ట్ ఇటరేషన్లో లైన్ ఇట్లా ఉంది, సెకండ్ ఇటరేషన్లో లైన్ ఇట్లా ఉంది in the second iteration, and now at the end of the third iteration the fitted model is like this. So you keep on watching this fitted line. So now if you look at the slope of if you look at the gradient of the cost function, the gradient is almost, చూడండి, if you look at the gradient of the cost function, it is almost 0. The gradient is almost 0. And can we claim that this is the best model possible? Yes. Best fit model for ఏంటి మనం ఇక్కడ ఏ డేటా తీసుకున్నాం? ద ట్రైనింగ్ డేటా. మనం తీసుకున్న ట్రైనింగ్ డేటాకి దిస్ ఈజ్ ద బెస్ట్ ఫిట్ మోడల్. ఓకే. ఇంకేమన్నా ఆప్టిమైజేషన్ ఉందేమో చూద్దాము. అంటే ఫ్యూ స్టెప్స్ ఇంకేమన్నా ఉన్నాయేమో ఇంకా ఫర్దర్. సో దిస్ ఈజ్ ద ఫైనల్. So this is the final 12 iterations. After 12 iterations, we are able to reach a gradient value which is almost 0. And we are able to fit the best model. When do you say the model is best? When do you say? See, if you calculate the total error now, the total error is very, very small quantity. What is the total error now? It is just 0.451, almost 0, the total error. So this is what we are doing. So we are using what is this method called? Calculating the gradient and if the gradient is negative, increase the parameter value. If the gradient is positive, decrease the parameter value. Okay, like that you keep on updating the parameter. You keep on updating the parameter. What is this method called? A method that calculates the slope of the cost function for a parameter value and try to change the parameter value so that the cost is minimized, and it keeps on doing that till the error is least possible error. So what is this approach called?
Gradient descent.
Good. This approach is called gradient descent approach. And in the last class, I have told you there are three types of gradient descent methods. Okay. What are they? There are three types of gradient descent methods. First one is batch gradient descent, and the second one is stochastic gradient descent, and the third one is mini batch gradient descent. Okay. In batch gradient descent, see how many training examples are there in our case? 1, 2, 3, 4, like that. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 examples. This is the last example, 19. Okay, 18th example. So there are 19 examples. Assume that there are 20. Assume that there are 20 examples in our case. Okay, let us come to the first method, batch gradient descent method. So in batch gradient descent method, what we do is, for all the 20 examples, we calculate the error. We calculate the error for all the 20 examples, and we calculate the mean value or the total error. We calculate the total error for all the 20 examples, and then we plot. We plot that. Okay, say this is the point. Now what we do is, we change the parameter. See, ఈ గ్రాఫ్ ఎట్లా వస్తుందండి? వాట్ ఐఎమ్ టాకింగ్ ఈజ్ హౌ టు అప్టైన్ దిస్ గ్రాఫ్. ఈ గ్రాఫ్ ఎట్లా వస్తుందండి? ఫర్ డిఫరెంట్ వాల్యూస్ ఆఫ్ పి, అంటే parameter, for different values of parameter, you calculate the total error for all the 20 examples, and ఆ రీడింగ్స్ని ప్లాట్ చేయండి. ఆ రీడింగ్స్ని గ్రాఫ్లో ప్లాట్ చేస్తే you will get this function. ఓకే, అండ్ వాట్ వీ డూ ఈజ్, ఈ ప్లాట్లో కర్వ్లో గ్లోబల్ మినిమా ఎక్కడైతే ఉందో, గ్లోబల్ మినిమా ఎక్కడైతే ఉందో, a curve that has only one global minima, a curve that has only one minima is called a convex curve. So this is a convex curve. It has only one minimum. Okay, only one minimum, and that is global minimum. Okay. So what happens if you want to do like this? See, how do you get this point? How do you get this point? ఎట్లా వస్తుందండి ఈ పాయింట్ గ్రాఫ్లో? ఏం తీసుకున్నాము? ఫర్ పారామీటర్ p ఈజ్ ఈక్వల్ టు 0.25. సో 0.25 స్లోప్తో ఇక్కడ ఒక లైన్ గీసి 0.25 స్లోప్తో ఒక లైన్ గీసి we calculate all the errors from E1 to E20, okay, and find out the total error for 0.25, okay. So 0.25 is the parameter, x value is 0.25 and the y value total error is say 12. So plot x is equal to 0.25, y is equal to 12 కాదులేండి, ఇది around say 11. So total error is say 11.25. సో ఇట్లా ఒక పాయింట్, ఇట్లా అన్ని పాయింట్స్ ఇట్లా వచ్చినాయండి. ఓకే, యూ నీడ్ లాట్ ఆఫ్ టైం, అంటే ఒక ఇటరేషన్కే మీరు ట్రైనింగ్ సెట్లో ఉన్న ఎగ్జాంపుల్స్ అన్నిటికీ ఎర్రర్ క్యాలిక్యులేట్ చేసి టోటల్ ఎర్రర్ ఫైండ్ అవుట్ చేసి దెన్ based on that value we update the weights, calculate the slope of the curve at that point, okay, and because the slope is negative, decrease the parameter value. Sorry, because the slope is negative, increase the parameter value. So this is time consuming. For in each iteration we calculate the error considering all the examples in the training set. Suppose ikkada ఎన్ని iterations చేసామండి మనం? 12 iterations చేసాం. సో in our case 12 iterations. ఒక్కొక్క iterationలో ఎన్ని ఎర్రర్ వాల్యూస్ క్యాలిక్యులేట్ చేయాలి? 20. సో 12 into 20, 120 calculations you have to do. Okay. సెకండ్ అప్రోచ్ ఏంటంటే we won't calculate error for all the examples in the training set. We randomly select. So what we do in second iteration is, in stochastic gradient descent approach, what we do is, ఈ training examples లో of all the training examples we randomly select one example. Let us say we have selected this example, and let us say we have selected this example. So for this example we calculate the error. That's all. Of all the training examples we calculate error for one example, and using this single error we take a decision. Using this single value we take a decision to update the parameter. అంటే ఇంతకు ముందులకి ఇప్పటికి తేడా ఏంటంటే, in the earlier case in batch gradient descent we calculate error for all the examples in the training set, and based on that value only we update the curve. We update the parameter, sorry. So in this case, in stochastic gradient descent we select randomly an example and calculate the error, and we take decision whether or not the parameter is to be updated based on this single error. Ante this error curve is only for one example now. We draw the curve only for one example, that's all. Whereas in the earlier case the error curve is for all the examples in the training set. రెండు ఎక్స్ట్రీమ్ కేసెస్ అండి. ఇన్ బ్యాచ్ gradient descent we draw the error function. The error function is for all the examples in the training set. Whereas in stochastic gradient descent, the error function is only for one particular example which is selected at random from the training set. That's all. Okay. And a via media solution between these two extreme cases is mini batch gradient descent. What we do is, because we have 20 examples here, okay, what I will do is I will make 4 batches. I will make 4 batches with a batch size of 5. ఒక్కొక్క బ్యాచ్లో 5 ఉంటాయండి, అంటే 1 2 3 4 5. సో ఈ 5, this is batch 1, and these 5, this is batch 2. So what we do now is we calculate error for batch 1, for examples in batch 1, and based on that error function, which calculates error for examples in batch 1, we update the parameter. Okay, so here how many batches we are able to make when the batch size is 5? There are 20 examples, and if the batch size is 5, how many batches we get? We get 4 batches. So how many times we update the parameter now? How many times we update the parameter? So for batch 1, we update the parameter. For batch 2, we update the parameter. For batch 3, we update that like that. So for each batch, we update the parameter. Okay. So like that, there are 3 approaches to update the parameter to find out the optimal parameter where the error is minimum. Um, so are you able to follow this? Are you able to follow? Where is that PDF document? Okay. So this is what we have learned till now. We have learned how to calculate cost, various ways of calculating cost, various ways of optimizing the parameters, and what are the various models that are available. This is a regression model. Okay. Uh, there are other models as well, say classifier. Okay. In addition to regression, we have classifier, unsupervised models, supervised models, like that. There are supervised learning models or unsupervised learning models. Based on the task and based on the input, we select appropriate model. Okay. And model will be evaluated, and the evaluated model, okay, you have come up with a best model. You have come up with a best model. Okay. Now, even then, you won't release the model in the market. Say your best model is like this: y cap is equal to say 3.2 times age. So assume that for this weight value, the error is the least possible error. Okay, 3 point times age ante ikkada in our case we are using the variable x1. Okay, so assume that this is the optimal value for the weight, and our error is the least possible error, and we are able to make the blood pressure predictions more close to the actual values using this model. Now your job is not over. You have evaluated the model only on training data. You have evaluated the model only on training data. Now what we do is we select a data set which is not used during training, and that data set is called test data. This data set also has both input and the target label given. ఈ డేటా సెట్లో కూడా ఏజ్ ఆఫ్ ఎ పర్సన్ ఎంత, వాళ్ళ యాక్చువల్ బీపీ ఎంత అనేది ఉంటుందండి. బట్ దిస్ డేటా సెట్ ఈజ్ నాట్ యూజ్డ్ for fitting this model. We have used so far only training data. So this is the best fit model for the training data only. Now, does this model learn properly so that it can predict weight of any person? We are yet to test. So what we do is, ఇప్పటి వరకు వాడని ఎగ్జాంపుల్స్ ఏమైతే ఉన్నాయో, ట్రైనింగ్ డేటాలో లేని ఎగ్జాంపుల్స్ ఏమైతే ఉన్నాయో, అంటే ఇక్కడ ఫర్ ఎగ్జాంపుల్ హాస్పిటల్లో ఒక 100 పేషెంట్స్ రికార్డ్ తీసుకున్నారు కదా, ఈ 100 పేషెంట్స్ కాకుండా ఇంకొక టోటల్లీ డిఫరెంట్ పేషెంట్స్ రికార్డ్స్ తీసుకొని 30 పేషెంట్ రికార్డ్స్ తీసుకొని వీళ్ళ యొక్క ఏజ్ని ఇన్పుట్గా ఇచ్చి అగైన్ యూ క్యాలిక్యులేట్ ద accuracy of the model or performance of the model. That is what is known as performance measure. ఓకే, ఇక్కడ ఎక్కడ పర్ఫార్మెన్స్ అనేది రాలేదండి. పర్ఫార్మెన్స్ అనేది it will come only when you test the model. So if the performance of the model is good, then we can go to any user who is in need of this model. Means you can go to any hospital and say, I have come up with a regression model which is very good at predicting the blood pressure of a patient given his or her age. So you can sell your product, your machine learning product, to any hospital. What is the advantage? What is the advantage? You tell me. ఎందుకండి ఇదంతా డాక్టర్స్ ఉంటారు, డాక్టర్స్ చెక్ చేస్తారు కదా అని అంటే, the advantage is now your model requires less time to check the blood pressure of the patient. Normally, if you want to check the blood pressure of a patient, you need a doctor. You need a doctor and a stethoscope. Okay, and it requires at least 10 minutes for the doctor to check the blood pressure. Whereas our learning model, if you just enter the age within microseconds or within milliseconds, it will predict his BP is so much. You don't require any doctor. You just require a machine learning algorithm which you have what do you call developed, and a person who types the age on the computer. That's all. You don't require a doctor because he only inputs the age. You can give less salary to that person, and moreover, it requires less time. You can check blood pressure for so many patients quickly. So quickly you can do that. Quickly you can do that, and you don't require a doctor for that. An unskilled person, a person who is not a medical graduate, can do that. That is another advantage at a faster rate. Okay. And already you have tested your model thoroughly. Okay. You have fitted the model using training data, and you have tested your model thoroughly on the test data, and you found that your model is very accurate in predicting the blood pressure, so it will give accurate results. Okay. Bhuvanagiri Naga Venkata Sai Sunil.
Yes, sir.
Okay, you are
Yes.
present. Venkatesh Rao, you stop recording. This is my lecture is over. You stop recording.